Hello everybody and welcome to my presentation. My name is Akram and in the following 5 minutes I will explain our recent work Invariant curvature-based Fourier shape descriptor. The presentation outline is going to be as follows. First I'll give you definition for shape descriptors, then their applications. After that I'll give you classification for these shape descriptors. Also I'll give you an overview about shape-based image retrieval systems. After that I'll explain in details the invariant curvature-based Fourier shape descriptors, which is the proposed descriptors. Also I'll show you some experimental results and conclude my work. What is shape descriptors? Shape descriptors are simply some set of numbers that are generated to describe a given shape. These descriptors should be unaffected by translation, rotations, and scaling. Classification of shape descriptors. Shape descriptors can be classified into region-based descriptors and boundary-based descriptors. These are some applications of shape descriptors. The focus in this presentation is going to be in shape retrieval. This is an overview about shape-based image retrieval. As we can see, it consists of offline and online stage. The matching is very important because it's part of the online stage. So the technique or the descriptors has to have very efficient matching. In the following slide, I am gonna explain the curvature-based Fourier descriptors. The curvature-based Fourier descriptors consists of 4 stages. In the following slides, I will explain each stage. In the first stage, we extract the image contour and we sample the contour at equal interval. In the second stage, we smooth the contour by using Gaussian function at different standard deviations, and we calculate the curvature. The third stage is very simple. We calculate the curvature scale image by thresholding the curvature at 0. The first 3 stages will convert the original image to a curvature scale image. And the advantage of the curvature scale image is that any rotation in the original image is corresponding to a shift in the curvature scale image. And this shift can be easily eliminated by using Fourier transform, as we're going to see in the next slide. The last stage is very simple. Just we apply the Fourier transform on the curvature scale image, and we take the magnitude to eliminate the shift, and we divide it by the first descriptors to make the descriptor invariant with respect to scaling. In our experiment, we used the MBIC7 database. This database consists of many sets, set A and set B and set C. These images are from set A. These images from set B, and these images from set C. Also we use a noisy database which is proposed in reference 48, and we call this one set D. These are the commonly used shape descriptors, and we compare our proposed descriptors against these 6 well-known shape descriptors. These are the experimental results, and as we can see from the recall precision curve that our descriptors in the set B outperforms all of the other techniques, and it gives perfect result in set A too. These are the experimental results for set A1 and set C. As we can see that our proposed descriptors give a comparable result to the other techniques in set A1, however didn't perform well in set C. And the noisy database, as we can see that our proposed descriptors outperforms all of the other descriptors. This is the overall result, and as we can see from the table that our technique gives better result than all of the other descriptors. Conclusion: the proposed descriptors outperform 6 notable descriptors in the most challenging database. Didn't perform very well in set C. And the overall performance is 12.53 higher than the CSS. Also, this descriptor used a simple matching procedure. Thank you for your attention.